Alrighty, so today we're looking at reciprocal and complementary angle identities. So the first thing we're going to look at is the reciprocal trigonometric ratios. So our reciprocal trigonometric ratios are the reciprocals, so 1 over something, of the sine, cosine and tangent ratios. So we have our cosecant, our secant and our cotangent ratios are our reciprocal ratios. So what we have is, instead of saying cosecant, we say cosec is equal to 1 over sine theta, which is our hypotenuse over our opposite. So sine is normally opposite over hypotenuse, so we just flip the fraction when we have the reciprocal. We have that secant, which we just call sec. So sec theta is 1 over cos theta, which is our hypotenuse over our adjacent, because cos is adjacent over hypotenuse. And our cotangent, which we just call cot theta, is 1 over tan theta, which is our adjacent over our opposite, because tan is opposite over adjacent. Now, the way that we can remember these three reciprocal ratios and what goes with what is the third letter of our reciprocal ratio goes with the first letter of sine, cos, tan. So if we look at cosec, the third letter of cosec is S, the first letter of sine is S. When we look at sec, the third letter is C, the first letter of cos is C, and then when we look at cot, the third letter is T, the first letter for tan is T. So that's how I remember what goes with what. Now, I believe on our reference sheet, we do have something on here to help us remember. So I can rub this out now. So what we have is we have our sec. So we have sec equals 1 on cos A, where we can't have a denominator equal to 0, so cos A can't equal 0. We have cosec is 1 on sine A, where sine A can't equal 0. And then for cot, we don't actually have that it's 1 on tan. We'll look at that in a little in tomorrow's or the next lesson about why it's cot equals cos on sine. Okay, so those ones are on our reference sheet. So the first two are on our reference sheet. Okay, so what we do with this on reference sheet. The reciprocal ratios, they have the same sign in our all stations to central unit circle as their related ratios. So, for example, in the third and our fourth quadrants, so in our all stations to central, for our all stations to central in our third and our fourth quadrants, we have that sine theta is less than 0 and that cosec theta is less than 0, okay? Because we have that in our third and our fourth quadrants, that's where tan and cos are both positive and sine is negative in those quadrants. Does that make sense? So our first example here, we want to state the quadrants where cot theta is negative. So we're going to look at our ASTC and we want where cot is negative. So cot theta is negative where tan is negative. So what that means is that tan is negative in our S and our C quadrants. So therefore, cot theta is negative in our second and our fourth quadrant as well. Okay, does that make sense how that works? So whatever it goes with, so remember third letter of our reciprocal goes with the first letter of our trig ratios. Another way that we can use our reciprocal ratios is we can find out the value of our reciprocal ratios using our right angle triangle and our SOHCAHTOA. So what we have is we want to find cosec theta, sec theta and cot theta for this triangle. I know I have an alpha down there, but we can just throw a little theta over the top if you like. Change that to a theta, sorry. Okay, so once we have that as a theta, remember we have SOHCAHTOA that is on our reference sheet. So what we have is our opposite side is 4, our adjacent side is 3, and our hypotenuse is 5. So when we're finding cosec theta, it is equal to the reciprocal of sine. So sine is O over H. So cosec is going to be H over O. So therefore, cosec theta will equal 5 over 4. Does that make sense? The next one, we have sec theta. Now, sec goes with cos. So cos is A over H, so sec is H over A. And so therefore, what we have is that our sec theta will be 5 over 3. And then our cot theta, cot goes with tan, or is the reciprocal of tan. Tan is O over A, so that means that cot is going to be A over O. And so therefore we have that cot theta is equal to 3 over 4. Okay? So that's one way how we can use that. Flip the page when you've copied that down for me. The next example, what we have is we have if sine theta equals -2 over 7 and tan theta is greater than 0, we want to find the exact ratios of cot theta, cosec theta, and sec theta. So what we have here is we have sine theta is equal to O over H. So what that means is wherever we want to put, where we've put our angle theta, it's up the top this time, what we're going to have is that our opposite side is going to be the 2 and the hypotenuse is going to be the 7. So what we need to do on our triangle first is to find the adjacent side. And how we're going to find our adjacent side, which is OHA, if we label our triangle, is we're going to have to use Pythagoras' theorem. Now, are we finding a long side or a short side for Pythagoras? Our short side. So when we're finding our short side, it's a squared equals c squared minus b squared. So we've just minus our b from our normal Pythagoras' theorem across. So what we will have is that our a squared equals 7 squared minus 2 squared, so our hypotenuse minus our opposite side. So a squared will equal 45. So a will equal the square root of 45. Can we simplify the surd of root 45? Yeah? What does it simplify down to? 3 root 5. Okay, because 9 times 5 is 45. 9, we can square root that to be 3. All your calculators should do that for you though. Okay, the next piece of information that we have is about when sine is negative and we have that tan is positive. So what we need to look at is we need to look at our ASTC. So when we look at our ASTC, we have that sine is negative. So sine is negative in our T and our C quadrants. And we have that tan is positive, so we're in our T quadrant. So our T quadrant is the quadrant that we are in. So we are, therefore, in our third quadrant. Okay, what we need to find is we need to find cot, cosec, and sec. So we have that cot theta is equal to our 1 over our tan theta, in case we've forgotten, which is equal to our A over O. We have that our cosec theta is equal to 1 over sine theta, which is equal to our H over O. and our sec theta is equal to 1 over cos theta, which is equal to h on A. So therefore, we have that cot theta will equal, we now know that our A value is 3 root 5. So cot theta will equal 3 root 5, which is our adjacent side, over our opposite side of 2. We have that our cosec, I've run out of lines, silly me. Cosec theta is, so cot is also positive. So cot is positive because we're in our T quadrant. Is cosec going to be positive or negative in our T quadrant? Cosec is related to sine. So sine is negative in our T quadrant. So cosec is also going to be negative in our T quadrant. So it's going to be negative h, which is 7, over our 2. And then our sec, sorry, you're going to have to fit it in here. Our sec theta is also negative in our T quadrant. So it's going to be negative 7 over 3 root 5. Sorry, I should have added another line. Okay. We can also rationalise that if we wanted to, or we can leave it like so. Any questions on that example? No? Okay. The next example that we have is to find the exact value of each expression. So what we have is cot 45 degrees. So let's just recall, cot is what reciprocal ratio? Tan. So we know that cot theta is 1 on tan theta. So what we're going to have is that cot 45, we're going to write cot 45 degrees, cot 45 degrees is equal to 1 over tan 45 degrees. Now, what do we know about 45 degrees? Why is that special? It's one of our triangles, okay? It's one of our exact values from our triangles. So if we were to draw our 45 degree triangle, we would have 1, 1, root 2, 45. So what is tan 45 degrees using our exact triangle? Tan would be opposite over adjacent. So tan 45 is equal to, what's opposite over adjacent? 1 over 1, right? So it's equal to 1. So I feel like we're not catching on as quickly. So tan 45 degrees is equal to 1 over 1, which just equals 1. So we substitute that into our denominator. So therefore, what does cot 45 degrees equal? It just equals 1. Okay, that one's the easy one because it's it's an acute angle for starters, and it's also in degrees, and you guys seem to work a lot better in degrees than radians. Okay. What we then have for our next one is sec. So sec squared though, 2 pi on 3. So what we have is that our sec squared 2 pi on 3 is the same. When we have something squared, it's sec 2 pi on 3 all squared. So instead of writing it out like that, we put our squared above our last letter of our sec. Okay, what is sec? Sec is cos. So it's going to equal 1 over cos 2 pi on 3 all squared. Okay, in fact, it's not just squared down the bottom, it's squared, the whole fraction is squared, which it doesn't really matter, I suppose, because the 1, we know that 1 squared is just going to be 1. Okay. What we have is cos 2 pi on 3. Now, if we were to look at our ASTC, we have 0 and pi is over here. Pi on 2 is up the top there. We have our ASTC. Where is 2 pi on 3, do we think? 2 pi on 3 is in which quadrant? Is it less than pi? Is 2 pi on 3 less than pi? Is 2/3 less than 1? Yes. So if we just think about the numbers and take the pi out of it, 2/3 is less than 1. So that means it's between 0 and pi. Is 2/3 less than a half? No, it's greater than a half. So that means that 2 pi on 3 is going to be between pi and pi on 2. Does that make sense? So thinking about your fractions, okay, where pi is 1, pi on 2 is a half, 2/3. Where does 2/3 fit in that? Okay, so what we have to do is we have our cos 2 pi on 3. Where's my pen? It fits between here. So that means to find our acute angle in our sine quadrant in terms of radians, we do pi, oh my goodness, this line, pi minus theta, where our theta is our 2 pi to find our acute angle. So this means it's going to equal 1 over cos pi minus 2 pi on 3. Now, what do I need to put in front of my... Oh no, we're cool for the moment. What is pi minus 2 pi on 3? Pi over 3, right? 1 minus 2/3 is a third. So we're going to have that it's going to be cos of pi on 3. Now, which quadrant are we in? We're in our S quadrant. Is cos positive or negative in our cos quadrant? Pardon? It's negative. So we need to put a negative in front of our cos there. Okay, the next thing we need to use, we're using our pi on 3. So our exact triangle for pi on 3 would help us out. So what we have is pi on 3. How many degrees is pi on 3? Pardon? So what's pi in terms of degrees? 180. So if pi is 180, what's pi on 3? What's 180 on 3? 60, right? So our 60 degrees in our triangle is down the bottom here. So pi on 3 is down the bottom. Pi on 6 is up the top because pi on 6 is 30 degrees. We then have our 1, 2, root 3. So what is cos pi on 3? We have that. If we're looking at our pi on 3, we have our adjacent and our hypotenuse here. So it is equal to 1 over negative a half all squared. Now, if we have 1 over a half, what does that become? What's 1 divided by a half? It becomes 1 divided by a half is just 2. Okay, so it's just that we have negative 2 all squared. And what's negative 2 all squared? 4. So that means sec squared 2 pi on 3 is just equal to 4. Does that make sense? Now, we can't put sec into our calculator. On our calculator, we don't have our sec button. But if we were to go, let's just put my calculator into radians really quickly and check whether we can do this on our calculator. if we put this line here into our calculator, we will get our answer. Try it. Yep. But we need to understand what's going on, right? We can't just go la 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 la. Okay? All right. So we're going to skip the working out with our cosec one, but we need to know what cosec is. So cosec is sine, because the third letter is an S. So what we will have is we'll have cosec 7 pi on 4. What's that going to equal? It's going to be 1 over sine 7 pi on 4. So in our calculators, if we go 1 over sine 7 pi on 4 and put that into our calculator, we get negative root 2, which is the correct answer. Look how much simpler that is by just having this bad boy help us out. Okay, you still need to understand what's going on, but you have this to your disposal. Okay, all right, that is our reciprocal ratios. What we're going to now look at on the next page is our complementary angle identities. So with our complementary angle identities on our next page, we have if this triangle that's been given to us here, triangle ABC, has angle theta, angle B equals theta, then our angle A is equal to 90 minus theta because of angle sum of a triangle, right? Because we have our right angle triangle, so we have 90 minus theta and we have theta. What we can do is we can say that angle B and angle A are complementary angles because they add up to 90. So a complementary angle adds up to 90. What we have, if I was to quickly label my triangle, I have my, well, actually we can't label the triangle because we have different things. But if I was to look at sine theta, it is equal to our opposite over our hypotenuse, which is B on C. Then what we have is that cos 90 minus theta is our adjacent over our hypotenuse, so our adjacent over our hypotenuse, which is B on C as well. So that means that our cos 90 minus theta is complementary to our sine theta because they equal B on C. Does that make sense? So pretty much we have our pair of trigonometric ratios that are equal, and we have that sine theta and cos 90 minus theta are the same. Now with our word cosine, right? So cos is cosine, complementary sine. See how that goes together? So sine and cosine are complementary together. Does that make sense? Cos and cosine. Okay? That also means that if we have cos theta, our cos theta is A on C, so our sine 90 minus theta is also A on C. So cos, if we have that cos is theta, we have that sine is 90 minus theta, and that's our A on C. Okay, our next one that we're going to look at is our tan. Our tan, and then our word for cot is cotangent. So tan and complementary tangent go together. Does that make sense? So tan and cotangent go together. So we have that our tan is B on A, okay, because tan theta is opposite over adjacent, B on A. And we have that cot 90 minus theta is B on A. So they go together. Okay, we also have the vice versa. So we have that cot theta is A on B and tan 90 minus theta is A on B. Okay, so cot and cotan go together. Then what we have is our last one is cosec and sec. So co for complementary. That's how we can remember what goes together. So we have cosec is C on B. Sec 90 minus theta is C on B. Whoops, I forgot to highlight this one too. Okay, so we're filling this in down the bottom. And then our last one here is, I haven't run out of colours. Sec theta is C on A and cosec 90 minus theta is C on A. Okay, so does that make sense how they all go together? Okay, so what we have is that sec goes with cosec. Okay, so complementary is at the front. That's how we know who goes with who. Now, we can simplify expressions and solve for unknowns using our complementary angles. And what we have is we have that we want to always work in terms of one or the other, okay? So with this first example here, we want to simplify tan 50 and cot 40 degrees. So we need to choose, do we want to operate in terms of tan or in terms of cot? I'm going to pick that we're going to work in terms of tan. So what we have to do is we have to use the fact that cot is cotan. So what that means is we will be using that we have that cot theta is equal to tan 90 minus theta. So what we will have is when we simplify this, we'll keep our tan 50 degrees, but instead of our cot 40 degrees, we are going to write that in terms of tan. So it's going to be tan 90 degrees minus 40 degrees. We then just need to work out what 90 minus 40 is. So we'll have tan 50 degrees minus tan 90 minus 40 is 50 degrees. What do we think tan 50 minus tan 50 is? 0, right? See how that works out nicely. How cool is that? How pretty. Works out as 0. All right, the last one we have here before you get into some independent work, hang on, we're nearly there, is we want to find the value of m. Boys, come on, just listen. We want to find the value of m if sec 55 is equal to cosec 2m minus 15. Now, we have sec and we have cosec. We know they go together because we have cosec, okay? Which one of these, cosec 55 or cosec 2m minus 15, do you think we should change? Sec or cosec? Sec. The reason why we should change sec is there's more going on with our cosec, right? With our cosec, we have 2m minus 15. It's a little bit more complicated. You can change it and you should still get the same result. It doesn't matter. But we are going to use the fact that sec is going to be our, we want to use the fact that sec theta is equal to cosec 90 degrees minus theta. I highlighted that the wrong colour. So that should have been orange, sorry. Because we're using that orange formula up there. So what we'll have is instead of sec 55, we are going to have cosec 90 minus 55 is equal to cosec 2m minus 15. Okay, so what we will have is 90 minus 55 is 35. So we'll have cosec 35 degrees is equal to cosec 2m minus 15. Now, as soon as they are both in terms of cosec, what we can do is we can divide both sides by our cosec. So we are then just left with 35 equals 2m minus 15. And from here we can solve for m. So we can add 15 to both sides to get 2m equals 50 degrees and then we can divide both sides by 2 to get m equals 25 degrees.